Hey guys, in this video we're going to have a look at a factorising technique used for solving algebraic equations, which is known as grouping by pairs. So these are the questions which we're going to have a look at today. So let's first get started with the first one. So the whole purpose behind this concept of grouping by pairs is to collect like terms from within the equation as part of the factorisation process. So if we have a look at this equation here, you'll notice that we can also kind of represent it as in the following way. Because s plus 5 appears within both terms, we can take it out as a common factor, and we could write it in this way. But then because it occurs in both terms, we can also pull out each of the components to have a common factor. So if we were to rewrite this again, a minus c, but leave our b term as what it was, we would have something like this. So this is what we're going to do in these examples, and it's the basis of this grouping by pairs technique. So let's pull out an s plus 5, and what are we left with? Well, in the first term, we're left with the value s, and in the second term, we're left with the value -2. And that's it. That's the factorisation by grouping pairs. So all we've done is we've pulled out what's left over from each of these terms. And you can do this from scratch. If this was all expanded out, you could get it to this point and then expand it and then factorize it further so that you end up with two sets of brackets. So that's the first one. We'll work through examples at different stages in this process. So example 2, we'll look at EF minus E plus AF minus A. So this time we've just got 4 terms. We don't have a set of brackets like we did in the previous example. So I hope you can notice here that we have a common term in the first 2 components and a common term in the last 2 components here. So the first thing that we should do to try and simplify this is pull out that common term from each of these. So we could have a look at it in the following way: equals EF minus E, and then as a separate term, AF minus A. Then if we pull out the common factor of each, here we can pull out an E, and that leaves us with F in the first term minus 1. And if we do the same thing here, we can pull out an A. That leaves us with F minus 1 again. And interestingly here, we end up with the same thing in each of the brackets. So as we did in the previous example, we can pull out the other components into another set of brackets. So here we can end up with E plus A outside of F minus 1. And it doesn't really matter the order that you write these brackets in. It's however you best visualize it. I usually visualize it best by putting the external components first, followed by the common factor, but you're welcome to do it the other way as well. So that's the second example. Third example, we have x squared plus 2x plus 3x plus 6. So here we need to do a bit of simplification first. We're not quite at our final form. Or we could do a bit of simplification here, but it may not actually benefit us. Let's have a look. First, we can try and pull out a common factor from each of our terms. So in the first 2 terms, let's write it out just as we did the previous question. 3x plus 6. And let's see what we can take out in terms of common terms. So in the first one we have x, that's common, and that leaves us with sorry, I left out the squared. That leaves us with x plus 2 inside the brackets. And from our second set of terms, we can pull out a 3, which leaves us with x plus 3 goes into 6 twice. And here we end up with an equation in the same form that we've had previously again. So 2 lots of x plus 2. X plus 2 occurs in both terms. Let's pull it out. I'll do it the other way this time. So we have x plus 2, and that leaves us with x in the first term plus 3 in the second term. So here, I mentioned at the start we can do a bit of simplification first. If we did, we'd end up with x squared plus 5x plus 6, which we could still get to this state here, but using a different technique. But by leaving it as is and pulling out common pairs or grouping pairs, we were able to work through a little bit of a simpler technique to getting to our answer in the end. So as you learn some of the different techniques, you'll see you may prefer doing this in some occasions or prefer going straight to this final step. It's going to depend on your preference and also what sort of result you're trying to work towards. If you know that there's a possible grouping or you recognize that early, then it may be best to try the grouping pairs approach. And let's look at the final one. So we have 4x squared plus 4x minus 3x minus 3. And as I mentioned in the previous example, we could go ahead and simplify this to combine the like terms. But as we did in the previous grouping pairs example, let's just take out some common factors. So we'll write 4x squared plus 4x as one term, and then minus 3x. And now because we're taking out a negative here, this needs to become plus 3 in this side. So that if you were to expand out this bracket, you would keep this 3 as a negative term. So just make sure if you're doing something similar that you are consistent with your terms or with your positive and negative values. So out of this first lot of brackets, we can take out a 4x, and that leaves us with x plus 1. And out of the second lot of brackets, we can pull out, we'll leave the minus there, but we can pull out a 3. And that leaves us in the brackets with x plus 1. And then by doing the same thing we've done previously, we've got 2 lots of x plus 1 in each, we've got 1 in each in each term. So pulling that out, x plus 1 leaves us with 4x minus 3. And that's it. That's the factorising by grouping pairs. That's the factorisation of this equation here. So that's just a couple of brief examples. Hopefully it sort of gives you a base understanding of sort of techniques you use to solve these simplifications or factorizations. That's it for this video. Thanks for watching. Leave any other questions you have in the comment section below, and catch you next time. Bye.